In this video, we're going to review the rules of exponents from the first section we did on exponents, section 4.1. So the first rule we'll look at is called the product rule. It's applied when we have two factors that both have the same base, two things being multiplied that have the same base, in which case the way we multiply those together is by adding the exponents. So for example, if we had x to the 7th times x to the 3rd, we get x to the 7 plus 3, or x to the 10th. Similarly, if we had y times y to the 3rd, we'd get y to the, now when we add these exponents, it doesn't look like there's anything here, but there's always a 1 if there's nothing written. So there's an implied 1. So we have y to the 1 plus 3, or y to the 4th. That's called the product rule. The next rule we looked at was the quotient rule. The quotient rule had to do with dividing, or having a fraction that had the same base in the top and the bottom as factors. So for example, if we had x to the 11th over x to the 4th, that would be the same as x to the 11 minus 4, or x to the 7th. We could also think of that as far as just canceling. If we had x to the 11th in the numerator, we'd have 11 x's being multiplied. In the denominator, we have 4 x's. And if we started canceling them out one at a time, I'd end up with extra x's on top, and I'd end up with 11 minus 4, or 7 extra. So with that in mind, if we looked at a problem like a cubed over a to the 7th, I can think of, I have 3 a's being multiplied on the top, and 7 on the bottom. Let's see, 1, 2, 3, 4, 5, 6, one more. And as I started canceling them out as common factors, I'd cancel out 3 on the top and 3 on the bottom, and I'd be left with just a 1 on the top and 4 a's being multiplied on the bottom. So again, this exponent is the difference between these two exponents. 7 minus 3 is 4. But in this case, there's more of that base on the bottom of the fraction, so it ends up in the denominator. The next rule we looked at was called the zero power rule. The zero power rule says if I have anything besides 0 taken to the 0th power, I get 1. So if I have a variable like a and I take it to the 0 power, I just say 1. If I have a number like 32, I take it to the 0 power, again 1. Our next rule is called the power rule. The power rule says if I have a base, take it to a power, and then I raise that to a new power, then I'm going to be multiplying the powers. For example, if I had x to the 7th, and then I took that to the 3rd power, I would have x to the 7 times 3, or x to the 21st. So take a good look and see the difference between the product rule, where we have the base appearing twice, and we add those exponents, and the power rule, where the base only appears once, but it has 2 exponents applied to it, in which case we multiply those exponents. So let's look at another example of the power rule. If we had numbers involved, like 4, and we had 4 squared, and we took that to the 4th power, for example, I'd have 4 to the 2 times 4, 4 to the 8th. Anytime I have a number to a power, I could work that out if I wanted to get a final answer with no exponents. And the way I do that on my calculator is I take the number 4, and then I use this power button, which is above the division. It looks like a little insert. 4 to the power 8. Hit enter, and it will give me the value. In this case, 65,536. The last rule we learned was called the expanded power rule. Let me scoot this up so we have room to look at that last rule. The expanded power rule says this: if we have some factors inside parentheses and they're taken to a power, then each thing in the parentheses is taken to that power. So let's look at a couple examples. For example, if I had 2x y cubed z squared, and I took that all to the 5th power, that would be the same as 2 to the 5th, x to the 1 times 5, x to the 5th, y to the 3 times 5, y to the 15th, and z to the 2 times 5, z to the 10th. And again here, if I had 2 to the 5th, I could use my calculator. I could calculate out 2 to the 5th, which is 32, and simplify to make 32 x to the 5th, y to the 15th, z to the 10th. Let's look at one more example of the expanded power rule. We'll look at one that has a fraction. Say we have negative 3a to the 4th over b to the 7th. And let's take that all to the about 6th power. So again, each of the factors inside is going to be taken to that 6th power. If I have a negative to an even power, that's going to give me a positive answer. So now I have 3 to the 6th, which again I use my calculator to find the value, 729. A to the 4 times 6, a to the 24th, and b to the 7 times 6, b to the 42nd. That would be my answer. So that's kind of just a review of all of the rules that we learned in section 4.1.